Thank you for coming to this session. My name is Yrineu Rodrigues. I am from Brazil, Fortaleza. And currently, I am the PTL for the NIC project. And today, me and John will present you some demos for some user case that we have on the NIC project and some features that we had added on the Beryllium release. And we will talk a little bit about some features, some some status of the NIC project, and we want to talk about the current architecture of the NIC project and how we are doing a PGA implementation and intent state machine. Okay. Today we have two demos for this. One demo for PGA implementation and another one for label management for mapping cells, right? Okay, I want to start talking about the current status for the NIC project on the Beryllium release. And the Beryllium release has been very productive for the NIC project. On this release, we had added some new features for the NIC. One of those features was bandwidth on demand, and another one was mapping cells that John will present for you today, and an intent state machine. This intent state machine will be responsible to keep the track for all those intents, and I will talk in more details the next slides. And we have a conflict resolution with using the graph on the NIC project. Another one, we had added some new features to allow the communication between given devices, block, doing a mirroring or a head direct action. And another one is KOS using the DSCP field, where we can do KOS for any groups for a given devices and just using intent, right? So, and another one is the NIC project has been suggested as our integrating model for ODL and NONOS. The Open Network Foundation Boulder project has described the NIC project as a closest prototype for this. Okay. And all of this was in Beryllium release. And in Beryllium release, we saw that the NIC project is open for new ideas and for new research, like PGA using graph compilation and intent state machine. We have an open community where we are able to listen about new ideas and to bring new developers and to deploy new solutions for the NIC project. Currently, the NIC project has some fields where on the core management, we have the mapping section that John will talk in more details in the next slides. We have the intent state machine together with event processing. And this, I will talk more detail about the intent state machine, the next slide, okay? And for the traffic forward side, we have our support for output, physical and virtual ports. All those features has been added on the Beryllium release. And now we are supporting redirect for SFC models. So this is a great integration with ODL NIC project with others OpenDelight projects. And another one is support for KOS. Now we are able to do KOS just using the intent, right? From the integration side, we have an OpenFlow render where we can integrate the neutron, OpenStack neutron, security policies using the described intent. And in another side is the PGA implementation that we are compiling the intents in just one to solve conflict. And another one is the integration with Boulder project that we want to integrate the NIC project with the ONOS project. This is our current architecture for the NIC project. Our entry point is the intent API, where we are receiving the intents. And using this intent API, we have intent CLI module, where we can create an intent using the caraf command line. The user can use the caraf command line to type a simple intent like this. Redirected to load balanced HTTP traffic from department to web. This is an intent. This is the desire of the user. It doesn't need to know which service will be used for that. The NIC project will know what service should handle this intent. So it means that the user will use this intent API to create your intent, just type in a simple English, and the intent API will create this intent and send to MD-SAL. And then, on the Beryllium release, we add this new feature called intent listeners, and the intent listener will listen about MD-SAL events. When the intent listener receives those events, we can share all those events that we want, filter events for all those modules on the NIC project. One of those modules is the OpenFlow render. Currently, this OpenFlow render is responsible to get this intent, extract all this information for this intent, and create the OpenFlow rules and send to all devices that compose this intent, right? And this OpenFlow render, we use the MD-SAL to send this. In this case, we have integration with other project. Other OpenDelight project is a OpenFlow plugin, where we will handle all those flows created by the NIC project. On another side, we have the Intergraph that will be responsible for compile those intents and solve conflicts. And when I say about a conflict, it means that we can have an application that wants to create an intent to allow all traffic between two devices, and we can have another application that wants to block all the flow for these two same devices. We have a conflict, and the PJ implementation is responsible to solve this conflict and generate the policies for that. I'll talk more details. Once the graph compiles those intents, it will generate these policies and will send to MD-SAL, to OpenFlow render, to handle our flows. This is our current architecture for the NIC project. Okay, we are using a DSL to describe our intent. When I say intent, I'm talking about a simple English language. So in this case, the user will use an abstracted, the user will use a simple English language to create your intents, like this. From IT department to marketing, allow sensitive traffic between 8 a.m. to 5 p.m. at high bandwidth. It means that the user wants to allow traffic between the IT department and marketing. And the second time, it will apply the QoS for this. It means that the NIC project will know that after the user creates this intent, the NIC project will know that it needs to use a handler to create the allow rule and to apply the QoS constraint. And the NIC project contains a REST API, where we are working to integrate this REST API with the Lux project to give to the user a friendly UI to be more easy to use this. Because currently, you can use the NIC project using the caraf CLI over our intent CLI module, right? And we are working to do a strong integration with the NIC project and the Deluxe project over this REST API. Another feature that we had added on the Beryllium release is the intent state machine. This intent state machine is used to identify the state of the intent and then provide a feedback about this intent. Currently, when we are creating an intent, or an intent using the NIC, this intent will be deployed just in time, right now. If I create this intent to allow all traffic between A and B, the OpenFlow rules will be applied right now. But we don't have the track for those intents. The idea here is to keep the track for all the original intents and give a feedback to the user for the state of this intent. And we had been proposed on the Beryllium release. Currently, we have this implementation there. We have the engine for intent state machine already implemented on the Beryllium, where all those intents will start as undeployed. Once we have this intent created and on the undeployed state, the NIC project will verify if all those nodes that compose this intent are up on the topology. Because do you agree with me that doesn't make sense to have the flows on the switch if the nodes is not up on the topology, right? And once we have the intent as undeployed, the intent state machine will try to create all those transactions to try to deploy this intent. So in this case, it means that the intent should go from undeployed to deploying state. When the intent is under deploying state, it means that all the flows are being created, and the NIC will try to push these flows to the switches. Once we have all those flows done on the switch, already deployed on the switch, it means that we have this intent on the deployed state. When we are receiving an event as a switch down or node down, it means that doesn't make sense to have this intent deployed anymore, because we don't have the endpoints there or switch there. It means that we should start the process to undeploy this intent and remove all those rules for all the switches. Okay, and once we have all those rules removed from the switch, this intent will go back to the undeployed state. And when we have all those nodes and switches come back again, all this process to deploy this intent will go back. We will restart. This is a basic scenario to give you an understanding for how the intent state machine works. Suppose that we have two users, Anna and Brad, and Anna contains 3 devices on the network, and Brad contains the 2 devices connected. And one application wants to create an intent that will allow the traffic between Anna and device, and Brad, sorry. And another application will say, redirect all traffic between Anna and Brad to a file service. Do you agree with me that we have 2 different intents with 2 different actions? It means that we should create 2 intents, just one match, just one OpenFlow match, and 2 different actions. Currently, if we create these 2 intents different, it will generate 2 different OpenFlow rules. With intent state machine, we are trying to create just one flow with 2 different actions. Once the user removes just one intent, it means that we can send an update for this flow, saying, hey, update this flow, just removing action 1. It is possible because now we are able to have a keep for all the track for the original intents and the transactions for each intent. Because once we are creating the process to try to deploy this intent, the intent state machine will create all those transactions to go to each state. And we can keep track for all processes, all those transactions. And this is another scenario we have all devices associated with ANA are turned off from the topology. In this case, these intent 1 and 2 are created but undeployed. So in this case, we will be in the first state. And the second step, some branch devices are turned on at topology, but ANA's devices are turned off yet. Do you agree with me that it doesn't make sense to have this intent deployed on the switch? And this, the next step, some ANA device comes back to the topology, and the NICs will receive some network events. It means that the NIC, the interstate machine will create the transaction to start the deployment process for this intent. In the next step, the interstate machine will create this transaction, and the NIC project using the OpenFlow render will create all those flows for those intents. This is our idea for the transaction creation. We are think to use the MD-SAL, right, to store our transactions. When the NIC project receives an event, like an intent edge or network node up or switch up, switch down, we are creating a transaction using the intent state machine. This transaction, once we are creating a transaction from undeployed to go to deployed state, we should create two transactions. It means that these two transactions will be dependent, and we can keep the track for these two transactions. Once the transaction 1 is done, we can start the transaction 2. But we can receive other transactions, other events for other intents or other network behaviors. In this case, we should create a separately transaction, and these three transactions can be executed in parallel. Okay. Now I'll talk about another great feature that we have on the NIC project. This is the Intergraph. The idea for the Intergraph is because any application can create intents using the same instance of the NIC project. But some of those intents can be conflicted. As I said, application 1 can create an intent to allow traffic between two given devices, device A and B. And another one can create another intent to block all the transactions for the device A and B. Now we have a conflict. The idea here is to try to solve this conflict and generate some edges. And then the OpenFlow rule, the OpenFlow render will manage this edge and create the OpenFlow rules based on. So we are using the MD-SAL to store the compiled graph, because two intents can be compiled and generate just one flow. It means that we have these two intents created by different users. Once the intent graph compiles them, it can be generated just one compiled intent. And then it can generate just one flow for that. This is an example for us. We have a demo for the graph where we have the finance group and the marketing group, and we are trying to allow traffic between marketing and finance. And on the other hand, we have an infected group that we should block this infected group to communicate with marketing. But infected group and finance group are the same group, because the device of the infected is part of the finance group. It means that we have a conflict here. Once the application 1 creates an action to block all the traffic between infected and marketing, and application 2 wants to allow the traffic from finance to marketing, we are facing a conflict here because the finance contains this endpoint. And the idea for the graph is to solve this conflict resolution. I have a demo here. I will demonstrate now. Here on this demonstration, we are using intent map, but the focus here is just for the compiled process. John will talk in more details about the mapping service, right? Here we are creating an intent. The first intent, the mapping. We will create the first group. This first group is called finance. And we'll put into this group some IP address that will be our devices, 2.1 and 2.2. Now we have a group created there. Another one is the group marketing. It's 2.4. And now I will create the group infected. And I will use the same IP address that the finance has, 2.1. Now, once we have all those groups, we can create intents using this group, using this mapping service. And I can create an intent, say, add intent from finance to marketing with action allow. It will create a flow to allow the traffic for both. And the other application can create another intent, say, from infected to marketing, action will be blocked. Now we have a conflict here. To solve this conflict, we should call the graph to compile those intents. When we are calling compile graph, the result will be this. We have original intents, finance to marketing, allowing, and infected to marketing apply block. Here is our conflict. And after that, the graph will solve this conflict. Just applying a rule for 2.1 and 2.4, applying allow, and 2.1, 2.4, applying block. This is how the intent graph is working to solve this conflict. For carbon release, we are thinking in integrate the interstate machine with graph. As you can see, once we have the intents compiled, we lost the original intents because all the renders will work with compiled intents. It means that we should create the intent, and the intent will be compiled by the PJ, and then the graph will compose those compiled intents. And the graph will send to MD-SAL, and we have some listeners for edges using the intent listeners model. Once we have all those edges on the MD-SAL, we will receive an event for edge up or edge down. In this case, the conflict has been resolved, and now we have the edges created there. And then the interstate machine will listen about this edge created. And the interstate machine will say, hey, I know the original intents because the interstate machine have access to the original intents, and the interstate machine will do the link for all those intents and the edges created. And then the interstate machine will create all transactions to deploy those edges on the switch. Now, John will talk in more details about label management for mapping sets. Please, John. Yes, of course. Off.
Thank you, Yrineu. Oh, sorry. Okay. Thank you, Yrineu. Okay, I'm Joon from the Hewlett-Packard Labs. I'm talking about the label management for the mapping service in the ODL NIC. As researchers, we've successfully integrated our previous work called PGA to the ODL NIC. Last ODL Summit, we've introduced our PGA from our latest research. Now we are available. We have a PGA available in the ODL NIC. So today, we are more talking about our research work for the next release of ODL NIC. One of the limitations in current ODL NIC is a mapping service. How to manage this mapping service automatically, and then how to manage endpoint, any key, any values in this mapping service. Currently, we need any expert knowledge or any database analysis for creating this mapping service and label trees in the manually. But we need a more automatic way for creating this mapping service, including some label trees and keys and endpoint. Because our current work is currently under review in one of the international conference. So in this talk, I wanted to share a very basic idea and then how to contribute our work to the next release of ODL NIC. Okay. As Yrineu showed before, this is the current ODL NIC architectures. Okay. We have this mapping service. Currently, we are using this hierarchical label tree for creating and composing intent. Okay. But this label tree is currently created manually using by the expert knowledges. And then we need an additional mapping service for endpoint and endpoint groups. As Yrineu showed the demo, we have to create the key with the specific IP addresses. But this has some limitations in scalability. Whenever we have a bunch of IP addresses and new endpoint, we have to associate this IP address to the specific groups manually. Okay? This requires many effort for management. So we are proposing here, so how to automatically manage these label trees, and then how to dynamically mapping any endpoint and endpoint groups. Our idea is that we can get any available attribute from the endpoint instead of IP addresses. Whenever we create any new endpoint, such as a new laptop or such a new virtual machine, they have their own properties. We try to analyze these properties for each endpoint, and then we can create this hierarchical tree, and then we can manage these memberships. Okay. Currently, there's LMS. Oh, sorry. We are proposing the LMS at Beryllium management service. This LMS sits between a high-level intent engine, such as ODL NIC, and infrastructure services, such as SDN controller and any cloud controllers. Instead of creating these label trees manually, we are getting some system state and available resources from the control plane, and then we can analyze this data, and then we can try to find available values, and then we can generate these hierarchical trees. Based on this label hierarchy tree, any intent engine can use this label tree for creating intents and compose intents by resolving the possible conflict. Finally, it can deploy this composed intent through the label management service, and then it can apply all detailed endpoint by tracing from the infrastructures. This has a very high scalability because we don't have any manual process for detecting the endpoint with the specific endpoint groups, because this system can automatically detect any new endpoint, and then it can notify, and then it can generate this detailed IP address with specific rules. Currently, we have a running prototype on the OpenStack. Now I'm going to show about more details about OpenStack implementation, but later we can apply this LMS on the ODL side. Okay. Currently, we have implemented the LMS in one of the OpenStack Neutron plugin. So currently, we are using the OpenStack Congress services for collecting all possible informations from different services in OpenStack. The Congress is on a policy management service in OpenStack. They are managing all different services available in OpenStack. Okay? Basically, we can try to give the label tree definitions without specifying any details about how to get this information from the infrastructures. We have an assumption that any cloud admin or expert can define these values. That means, for example, it's available zone. So we can, any admin can specify this available zone from, in terms of how to get this information from the infrastructures. In terms of users, we don't have to care about these values. We can just define, okay, I want to use the any location label tree with available zone and host. So we can take, LMS can take this given input, and then it can automatically generate these types of data log rules. Because currently, Congress is using the data log for managing this data. So we don't have to generate this complex data log. We can just give this simple input, and then LMS can automatically generate this data log. By taking this data log in the Congress can try to collect all available information from the infrastructures. This is the example in the tables stored by Congress. Currently, we have 4 available zones and 5 hosts. Congress can collect this table. Based on this table, LMS can generate this hierarchical tree. If we have any updated values in this table, LMS automatically update these tables. Okay. For example, if we have one more host for the more virtual machines, and then we can also add this new host in these label trees. Currently, we have an open API from the ODL NIC mapping service. We can store this label tree to the mapping service. And then we can use this label tree for creating any high-level intent. Okay. This is one of the examples. Okay. Basically, we want to allow HTTP traffic from this EPG1 to EPG2. Okay. Currently, we are defining this EPG1, any virtual machine or any endpoint whose tenant is admin and located in the available zone 1. And EPG2 is located in the available zone 2. Okay. As you can see in this instance, we don't have any specific details such as IP address or MAC address. We can just create a very high-level intent. Okay. By taking this group of endpoint, LMS automatically create this data log for detecting any endpoint based on these conditions. Okay. Whenever you created any virtual machines, it can detect the new virtual machine based on this condition, and then it can default this new member to the mapping service. If you created one more virtual machine here, it can automatically detect its VM ID, port ID, IP address, and then we can generate detailed OpenFlow rules. Okay, I'm going to show our current demonstration. 끝났어?
Let's plug in. Okay.
Okay. This is the OpenStack dashboard called Horizon. We have extended our LMS services under admin menus. Okay. So currently, we are defining a label as a key and values. Okay. There are 3 keys: application, tenant, and locations. And then we can define the values of this input actually from the cloud admin or any expert. As you can see in here, okay, for example, in the host values, so we are defining how to get this host information from the infrastructure. Currently, we can get this host information from the Nova database. There is one host table. We can get this information from the this Nova databases. Okay. So cloud admin or expert can define these types of key and values. And as users, we can just use this key and value set for creating our label trees. Okay. Currently, we are just defining label tree with only a list of values without any specifying details. Okay. If you want to create any user label tree, you can define the user label tree with the user values, or you can give them some hierarchical orders in this value set. Our ongoing work is currently we are assuming that we have to get this hierarchical order from the user, but our another work is we are trying to find this hierarchical relationship automatically without any assumptions. Here, okay, based on this input of a label tree, LMS automatically creates a new label tree based on this input. Okay. As you can see in this menu, okay, it can create this label tree. Currently, we have two available zones, AG1 and AG2. There are two compute nodes under the AG1, the one compute node in AG2. Okay, now we are trying to update any cloud data. For example, I want to move this one host compute from the ODL zone 1 to ODL zone 2 using the OpenStack APIs. Okay. There it is. Yeah, this is the default admin menus in the OpenStack. We can use the host aggregate menus. It is managing the ODL zone and host mappings. Okay. Basically, we are updating this ODL zone and host mappings. Okay. I'm going to move the com2 from the ODL zone 1, and then I can attach this com2 to the ODL zone 2. Okay. This is just examples. You can change anything in this infrastructure using the OpenStack standard APIs. Okay. I want to show how LMS update these changes automatically. Okay. As you expected here, so LMS updated these label trees. We just moved the com2 from ODL zone 1 to the com2, ODL zone 2. Okay? Whenever we have a new compute node, a new ODL zone, we can update this label tree, and then we can notify to the ODL NIC side. Now I'm going to show how to manage the endpoint and endpoint groups. Okay? Here, we are currently using the Boolean expression over each set of labels for defining EPGs. For example, in this EPG2, we are defining this EPG2, which is any virtual machines whose tenant is demo and located in the Ubuntu compute node. Okay. We can just define a group using these Boolean expressions. We can take this input from the other intent engines, such as ODL NIC. Now I'm going to create one more EPGs using our interface. Okay, I want to create a new EPG3. Okay, any virtual machines whose user is located in the ODL zone 1. Okay, simply we can define location label tree and ODL zone 1 as a key. Basically, we can take this input from the other intent engines, and then LMS can manage this membership. Currently, we have no VM in the current OpenStack environment. So as you can see that here, so currently we have two virtual machines that are associated in this EPGs. These EPGs, these virtual machines whose owner is admin. Okay. I want to show the current list of instances in this environment. Currently, we have two virtual machines created by admin users. These two virtual machines are located in the ODL zone 2. So why we didn't see any virtual machine in the ODL zone 1? And now I want to remove one of the virtual machines from this menu. So as we expected, LMS has to update these memberships automatically. Okay. Currently, I'm removing this web VM1 from this instance menu. sorry, I'm just running on this OpenStack in one of my virtual machines in laptop. So this is very slow. Okay, I just removed one virtual machine. Okay, and then we can see here. I want to show the EPG1. EPG1 is a virtual machine whose owner is admin. Okay, so as you can see, there is only one virtual machine as endpoint. Likewise, whenever we have a new endpoint as virtual machine or new network port, it can manage this membership. That means we don't have any new management system for endpoint groups. Okay, so we don't need any infrastructure changes. We can just detect these changes from the infrastructure, and then we can generate the new rules based on our high-level intent. Okay. This is my demo, and then we can wrap up. Okay, I hope this LMS will be available in ODL NIC soon because we need more feedback. Like we have actually very much feedback from our last PGA work after we presented the PGA work in the last ODL summit. We are also getting the more feedback from the all communities in these new topics. Okay, thank you. And then, do you have any questions? Do you want to say anything?
Yeah, I think so. So thank you so much for your time in this session. And we want to listen about your feedbacks for this and go to talk with some NIC guys and to meet the NIC project and work with us. Thank you so much for your.